In the previous video, we pre-processed our data and we're now ready to extract the word frequencies to be used in our prediction problem. The TM package provides a function called document_term_matrix that generates a matrix where the rows correspond to documents, in our case tweets, and the columns correspond to words in those tweets. The values in the matrix are the number of times that word appears in each document. Let's go ahead and generate this matrix and call it frequencies. So we'll use the document term matrix function calls on our corpus that we created in the previous video. Let's take a look at our matrix by typing frequencies. We can see that there are 3,289 terms or words in our matrix and 1,181 documents or tweets after pre-processing. Let's see what this matrix looks like using the inspect function. So type inspect and then frequencies, and then in square brackets we'll look at the documents 1000 through 1005, and we'll look at the words 505 through 515. In this range, we see that the word cheer appears in the tweet 1005, but cheap doesn't appear in any of these tweets. This data is what we call sparse. This means that there are many zeros in our matrix. We can look at what the most popular terms are, or words, with the function find, freq, and then terms. We want to call this on our matrix frequencies, and then we want to give an argument low freq, which is equal to the minimum number of times a term must appear to be displayed. Let's type 20. We see here 56 different words. So out of the 3,289 words in our matrix, only 56 words appear at least 20 times in our tweets. This means that we probably have a lot of terms that will be pretty useless for our prediction model. The number of terms is an issue for two main reasons. One is computational. More terms means more independent variables, which usually means it takes longer to build our models. The other is in building models, as we mentioned before, the ratio of independent variables to observations will affect how good the model will generalize. So let's remove some terms that don't appear very often. We'll call the output sparse, and we'll use the remove sparse terms function, which takes as a first argument the name of our matrix, frequencies, and then as a second argument, the sparsity threshold. The sparsity threshold works as follows. If we say 0.98, this means to only keep terms that appear in 2% or more of the tweets. If we say 0.99, that means to only keep terms that appear in 1% or more of the tweets. If we say 0.995, that means to only keep terms that appear in 0.5% or more of the tweets, or about 6 or more tweets. We'll go ahead and use this sparsity threshold. If you type sparse, you can see that there's only 309 terms in our sparse matrix. This is only about 9% of the previous count of 3,289. Now let's convert the sparse matrix into a data frame that we'll be able to use for our predictive models. We'll call it tweetSparse and use the as.data.frame function called on the as.matrix function called on our matrix sparse. This converts sparse to a data frame called tweetSparse. Since R struggles with variable names that start with a number, and we probably have some words here that start with a number, let's run the makeNames function to make sure all of our words are appropriate variable names. To do this, type col names, and then in parentheses the name of our data frame, tweetSparse, equals make.names, and then in parentheses again, col names, in parentheses, tweetSparse. This will just convert our variable names to make sure they're all appropriate names before we build our predictive models. You should do this each time you've built a data frame using text analytics. Now let's add our dependent variable to this dataset. We'll call it tweetsparse negative and set it equal to the original negative variable from the tweets data frame. Lastly, let's split our data into a training set and a testing set, putting 70% of the data in the training set. First, we'll have to load the library ca_tools so that we can use the sample split function. Then let's set the seed to 123 and create our split using sample.split, where our dependent variable is tweets sparse $negative, and then our split ratio will be 0.7. We'll put 70% of the data in the training set. Then let's just use subset to create a training set called train_sparse, which will take a subset of the whole data set, tweetsparse, but only take the observations for which split is equal to true. And we'll create our test set, testsparse, again using subset to take the observations of tweetsparse, but this time for which split is equal to false. Our data is now ready and we can build our predictive models. In the next video, we'll use CART and logistic regression to predict negative sentiment.